So hello everyone, and today we'll be seeing one of the problem from Geeks for Geeks. The problem says game of XOR. So we are given an array of integers and we are asked to have a subarrays, and within the subarrays perform an XOR. And when we perform an XOR, we will get a value, and within all the subarrays XOR, whatever can be possible from the parent array, XOR those results and give us answer. Straightforward, pretty simple. So we have an array, for example, like this. The subarrays are 1, 2, 3, and whatnot over here. So XOR of these elements are respectively shown in front of them. And then once we get an XOR, we return the value. Same goes for the example 2 as well. For 1, 2, we have 1, 1, 2, and 2 as a subarray, and then we have XOR of all of them. So before jumping directly within the code, we wanted to make few things very clear that how XOR works. So how XOR works is XOR has two functionalities basically. So for an XOR, if XOR is made like for an element A, let's take an integer A, XOR with A gives us 0, and A XORing with 0 gives us A. So these are the two basic axioms of that XOR. Now, with this in mind, we can deduce that hey, if A XOR A XOR A XOR A like this 4 times, what would it give? So this we can deduce it to something like A XOR A would give us the result as 0, and you know that 0 and A gives us the result as A, and ultimately A XOR A is 0. So we can say that entire the string is 0, and if I go ahead and deduce it to one more XOR, then you know that hey, the entire string was 0 here, and if I'm XORing it again with one more element A, then the answer would be A. So things are pretty much clear over here that if the element occurs at even number of times, then the XOR is 0, and if the element occurs at odd number of times, the XOR is the element itself, in this case A. Now we need to know that how many times does a number occur in subarray. So we need to know that how many times does it occur. So let's take an array first of all. So we have an element x, a number n at index I. So let's take it a of I instead then. Okay, so starting from a of 0 and ending at a of n minus 1, where n is the total size of the array. Now we need to know how many times a of I occurs in subarrays. How do we know this? So we need to first dissect it into a fashion that how many times it occurs on the left subarray and how many times it occurs on the right subarray. So for doing that, let's understand what can happen upon the left. So it can go from 0 to the current ith position, and from the right, it can go from I to n minus 1 position. In this case, it will have 0 to I means it is I plus 1 values. So you take from 0 to 1, including 0 as well. So you will have I plus 1, and when you say that hey, I wanted to go to I to n minus 1, you will have n minus I. So you're taking the difference from this point to this point. So, and including 1 because you're not excluding the last bit. So it is something like I minus 0 plus 1. So it came out to be I minus 0, which was the rightmost to the leftmost, but we are not ignoring the leftmost or rightmost, so 1. And in this case, it was the rightmost was n minus 1, and the leftmost was I plus 1. So that is what n plus 1 and n minus I is, and hence we know that now left and right. So I can get that count of a of I can be the left side and the right side. So n minus 1, sorry, n minus I multiplied by I plus 1 because we are taking both the sides. Now I know the count, I know this axiom. What is stopping me from? Like I'll get the count how many times a of I has occurred, and if it is even, I'll just take 0 XOR, and if it is odd, I'll take the element itself, in this case a of I. So without any further delay, let's get started. So here I'll first take int n as length, a of length, where array would be a. Let's make some space for our coding. Yeah. Int XOR, this would be our result, and that is the one we are going to return. We are going to iterate one by one from starting from I is equal to 0, I is less than n, and I plus plus. And once we wanted to know the count, that means int cnt is equal to, how would I get the count? It is from this formula which I have mentioned over here. I'll just copy and paste this formula over here. And if you know the drill, if count is modulo 2 is not equal to 0, means the count is odd, I'll just go ahead and XOR this one. XOR is equal to a of I. Now, yes. It so far so good, it seems. Let's compile it for any compiler errors, and that's it. The code. Let me check for any compiler errors if I'm having. It seems not. Oh, okay. Before submitting, I have few optimizations as well, that you can skip few computations and go beyond. So stay tuned. So if I'm going to submit this one, okay, well, it passes. Now, if I'm going to go ahead and say that for I is equal to 0, oh, I know that I plus 1 would be an odd number. Okay. And what about I is equal to 2? So if I go ahead with I is equal to 2 and I plus is equal to 2, in this case, I'm skipping all the z1s, and let's submit this one. Oh, okay, sorry. What is missing here is I plus 1 needs to be done instead of this. Okay, 0 plus 1 it is 2. And once I submit this, oh, cool. So 0 plus 1 was something odd number, and if 0 was any odd numbers, then obviously this value would be an even, and which we don't want. So we started from 0 and we incremented the 2. Again, we can go ahead and check the length as well. So if the length of an array is even, we can go ahead and just return it. Again, these are minor optimization, but it won't cost any, like it won't significantly improve any complexities. The baseline complexity would always be time complexity, which means always be O of n, and the space complexity is the constant, since we didn't use any space. So that was all about it. It required a math a bit, or some bit operations, and some bit understanding of how things work. If you wanted to get the code, I'll paste the code in the comment below. Do check it out, share your thoughts, and click the video on your right so that I can see you in the next one.